All right, so on section 5.6. And we're going to talk about, let's get started, guys. Let's get started. We're going to talk about the triangle inequality. First, though, we're going to talk about a couple of other things that lead up to the triangle inequality. So I'm just going to call this property. All right, so I'm going to say if A equals B plus C. So we're talking about some numbers here. And we're going to say C is greater than 0. C is positive. So let's think about this. So we get A by adding some number to B. How do A and B have to compare? So C is a positive number, bigger than 0. So to get A, I'm adding something to B. Which one has to be bigger? A has to be bigger, right? If to get A, I'm adding something to B. That means B is smaller than A. A has to be bigger. So an example would be 7 equals 5 plus 2. Well, 7 is bigger than 5, right? Yeah. 7 is also bigger than 2. So I'm getting this number by adding something to one of these. This one has to be bigger than the others. We're going to say if A equals B plus C, A is greater than B. Makes sense, right? All right, so we're going to apply this in a couple different ways. Yeah.
You're adding a negative.
So that's why we said, you're exactly right though. That's why we had to say C is greater than 0.
All right.
If you're adding a negative, that would not work. That's exactly right. So that we had to be careful and say that we're adding positive numbers. That's a good catch on the detail there. So now we're going to use that for an exterior angle theorem corollary. And remember we said a corollary was just a theorem that we could figure out easily from another one. I think of them as bonus theorems. Maybe we could figure them out really easily. Well, first let's remember what an exterior angle is. So we talked about this back when we talked about the triangle side. So I'm going to call that angle 1, angle 2, and angle 3. Angle 1 was the exterior angle. Do you remember when we talked about this, what we called angle 2 and angle 3? They're the remote interior angles. They're remote because they're far away from this one, and they're interior because they're inside the triangle. So these are remote interior angles. Do you remember what we said about the exterior angle and the remote interior angles? Karen? Right. So our theorem was that the remote interior angles added together equals this one. Because all three of these together have to equal 180, and this angle 1 plus this one has to equal 180. So whatever that is, plus this is 180, whatever that is, plus those two together is 180. So 2 and 3 together have to be the same as 1. So we'd say measure of angle 1 equals a measure of angle 2 plus the measure of angle 3. Now that was our exterior angle theorem. Well, looking up above here, what does that tell us about angle 1, angle 2, and angle 3?
1 is greater than 2.
1 is greater than 2. And does it matter which order I put these in? 2 and 3? So what does it tell? Also tells us measure of angle 1 is greater than measure of angle 3. That is our remote exterior angle, our exterior angle theorem corollary. The exterior angle is bigger than either of the two remote interior angles. Yes? Okay, good. And if we were to say this in words, our external angle theorem corollary, we would say the external angle exterior angle measure is greater than the measures of the remote interior angles. So that's what we said over here. Measure of angle 1 is bigger than measure of angle 2, and the measure of angle 1 is also bigger than the measure of angle 3. So that's one inequality in a triangle. It's not the triangle inequality, but it's one that we can talk about and we can use. And it's kind of nice. I was telling people in the math office, the other teachers, it's nice that we finally get to talk about inequalities. In math, we talk about equations a lot. Things equal this and things equal that. But inequalities are really important because lots of times things aren't equal, but you can figure out things because they're not equal. All right, we good there? Let's look at an example. So here's a picture that we're going to look at. I'm going to call this angle 1, 3, 2, and 4. And I want to know, for this, we want to know how do measure of angle 1 and measure of angle 4 compare? That's what the question asks us. Well, let's figure out what we do know here. What kind of angle is angle 1? It's obtuse. It's an exterior angle. So what can we figure out about what kinds of relationships can we figure out here? Measure of angle 1. If we add 2 and 3 together, that equals a measure of angle 1. So what does that tell us about the measure of angle 1 compared to
Greater than 2.
measure of angle 2 and measure of angle 3? Well, let's look at angle 3. What do we know about angle 3 and angle 4? They're vertical, yes. And that tells us they're the same. The measure of angle 3 equals the measure of angle 4. So what does that tell us, Kaylee? So measure of angle 1 is greater than the measure of angle 4. Measure of angle 1 is bigger than the measure of angle 3, and angle 3 and 4 are the same. The measure of angle 1 has to be bigger than the measure of angle 4. We don't know how much bigger, we just know that it's bigger. And sometimes that's all we need to know is it bigger or smaller? For my math class that I'm working on, the last homework assignment that I worked on, everything had to do with inequalities. I had to figure out things about inequalities. All right, questions on that example? All right, another idea, another way we can talk about comparing parts of triangles. I'm going to say in any triangle, the largest side, I'm just going to say the large side is opposite the large angle. The small side is opposite the small angle, and the medium side is opposite the medium angle. And this really pretty intuitive idea. If we have a big angle in a triangle, this side over the meet that joins those two has to be pretty big. If we have a small angle, the side that joins them has to be pretty small. It's in between, it has to be somewhere in between. So that's all this is saying. Biggest side is opposite the biggest angle, the smallest side is opposite the smallest angle, and the medium side is opposite the medium angle. We say mediumist? The mediumist side is opposite the mediumist angle?
Yeah.
Is there such a thing as mediumist? The most in the middle? Pretty, makes sense, right? So let's look at a couple of examples with this. So here's my triangle, not drawn to scale. So we have to believe what the diagram tells us, not what my picture looks like. Which angle is largest? What do you think, Carolyn? Angle C? This side is the biggest side, the longest side. Angle C is the biggest angle. And when we say across or opposite from, we mean directly across the triangle. So that would be our answer there. What would be the smallest? Angle B. Because it is opposite, directly across from the smallest side. Really easy idea, right? And it works both directions. We can figure out things about the sides and the angles. So for this next one, what I want to do, I'll put up a picture, and I want everybody to, in your notes, I'll tell you what I want you to do, and then we'll talk about this. Make a list. Make a list in your notes. Everybody write this down. Shortest to longest side. So looking at that triangle, make a list. Rank your sides shortest to longest. If it helps you can draw the little arrows like I did on the one above.
It's really colorful.
Do we get it? Which one's the shortest? AB. And that's because it's across from The smallest angle. Shortest to longest. How about which one is the medium? AC, because it's opposite the medium angle. And the longest, that only leaves one side, CB. And if it helps you to draw the arrows, that's fine. All right, so let me ask you a question now. Remember when we talk about right triangles, we say the hypotenuse is the side across from the 90-degree angle. The hypotenuse is along the side. What does that tell us about a right triangle? The right angle is the biggest angle in a right triangle. So I said it's not drawn to scale. You have to go by the way I label it, not by the way it looks. This one's not a right triangle. I just meant in general. In a right triangle, we said the hypotenuse is the longest side and it's across from the 90-degree angle. That tells us that the 90-degree angle is the biggest angle in a right triangle. Because if we had another angle that was bigger than 90 degrees, what would happen? It would be obtuse, and then all the angles inside the triangle would add up to more than 180, right? We'd have a 90-degree angle and something bigger than a 90-degree angle, and then it wouldn't work. Okay. I like these where all different kinds of things kind of come together. All right, the last thing, the big thing for today, the triangle inequality. Really important theorem, and when we talk about it, it'll seem kind of simple, not much to it. It shows up in a lot of different places. So I'm going to write it out first, and then we'll talk about what it means. The sum of the lengths, and when I say sum, what are we talking about when I say sum?
All of them added together.
We're adding. Sum means add. Sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let's draw a picture, and we'll say what this is telling us. So I'm going to call this side 1, side 2, and side 3. Side 1 plus side 2 has to be greater than side 3. Side 2 plus side 3 has to be greater than side 1. And side 1 plus side 3 has to be greater than side 2. So if I add up the lengths of any two of the sides, it has to be bigger than the third side. And the reason why is, let me draw, I'll make my line a little thicker. So here's the side of a triangle. Here's another side, and here's a third side. These two don't add up to be more than the blue side. What's the problem there? It's not a triangle. It won't connect. I can't stretch this down here to meet this side, so this can't connect. And notice we said greater, not greater than or equal. If they're equal, here's my side. Oops, I wanted to do this. If they're equal, there's the blue side. There's the green side. And there's the red side. If they're exactly the same length, I can't make an angle. They have to stay flat on top of each other. So I can't make an angle. I just get a straight line, or a straight segment right on top of each other. So that's why the two sides have to add up to be bigger than the third side. Otherwise, we can't make a triangle out of it. They can't connect, or they're just flat on top of each other. Well, like I said, triangle inequality, easy idea, but shows up in lots of places where you wouldn't imagine that it's going to show up. So let's look at a couple of examples of kind of problems that you might be asked to do with a triangle inequality. You have questions before we go on? I love the triangle inequality. For all these examples, we're going to say, can we make a triangle? So here are our sides. 6, 13, and 8. So those are our side lengths. So the way we solve this problem, the way we look at this is we think, is this going to work with the triangle inequality? So we say 6 plus 13 equals what? 19. Is that bigger than 8? Yes. 6 plus 8? 14. Is that bigger than 13? Yes. And then 13 plus 8? 21. Is that bigger than 6? Yes. So yes, we can make a triangle.
Are you going to have to actually draw it?
No, you don't have to draw it. So let's look at another one. Our sides are 9, 12, and 3. So we test it out with the triangle inequality. 9 plus 12 equals 21. Is that bigger than 3? Yes. 9 plus 3? 9 plus 3 equals 12. Is that greater than 12? No. So our answer is no, we can't make a triangle. Those two sides would make it flat, right on top of each other. Precise.
I just got lucky.
Anybody see the shortcut here?
Add up to the smallest, see if they equal more than the biggest.
Add up the two smallest and see if they are more than the biggest side. Because we know if 13 is bigger than 6, anything we add to 13 is going to make it still bigger than 6. So what we really need to do is add the two smallest sides and see if it's bigger than the biggest side. So for these kinds of problems, we can just add the two smallest sides. But of course, in math, we like to add another little wrinkle into the problem. So let's do that. Questions on this before we go on? All right, so for this one, we're going to say two sides of a triangle are 7 and 9. What are the possible lengths for this third side? So we're going to do this problem just like we did the other one. I'm going to say the sides are 7, 9. We don't know what the third side is, so in math, what do we like to call something when we don't know what it is? X. 7, 9, and X. And we're going to do the triangle inequality for each of the sides in pairs. So in order to have a triangle, we have to have 7 plus 9 greater than X. Well, what's 7 plus 9? 16 is greater than X. We also have to have 7 plus X greater than 9. Well, now I get X by itself, subtract 7. So X is greater than 9 minus 7 is 2. So X is greater than 2. And then let's do the last one. 9 plus X greater than 7. And when I subtract 9 from both sides here, what happens? X greater than, what's 7 minus 9? Negative 2. Can we have negative sides on a triangle? No, so we just ignore that one. So this says X is between 2 and 16. So if X is between 2 and 16, we can make a triangle with those side lengths. The other way we could write that is 2 less than X less than 16. So this tells us X is between 2 and 16. All right, questions there? Yes. Yes. Mm-hmm. And if it was less than 2, then you wouldn't be able to, they would be too small and they wouldn't connect. All right. Homework. And also part of our homework is the 5.6 dynamic activity. So the dynamic activity in your online textbook, Power Geometry, it's in your to-do list. So do that as part of your homework as well.